So today we're going to talk about the area of a triangle. And when finding the area of a triangle, we're going to be using this formula over here, which will be provided to you on the state test in April. But the area of a triangle is, the formula is 1/2 times the base times the height. B is the base, H is the height. But the key to finding the area of a triangle is that we need to be able to identify what is the base and what is the height, particularly the height of the triangle. And we've talked about 3 kinds of triangles so far this year. The first one being an acute triangle, which is in the first diagram. And when we're working with an acute triangle, the height is inside the triangle. So AF is the height. I often label it H. And our base is BC. So 1/2 base times height. My H not very good here. Try it one more time. In an obtuse triangle, the height is always outside of the triangle. It is the dotted line, in this case CT is our height here. And the base is the BA. In a right triangle, our height is here. It's one of the legs, and since I called AB the height, then BC is going to be the base. You could switch those around. So we need to be able to identify the height when we come over here to actually figure out, well, what is the area of the triangle? So we take a look at this particular problem here and what we want to identify. Well, what is the base and what is the height? Well, we have an acute triangle. We have 3 acute angles. It just so happens that that dotted line there is our height. And again, our height is inside on an acute triangle. Then that must mean that the base is 16. And then we can fill in the formula that will be provided for you. And that is, to find the area, we're going to do 1/2 times 16 times 13. Type it into Desmos, type it into your calculator, whatever works for you. By the way, I don't really type in 1/2. I usually do 0.5 times 16 times 13. And eventually here, you get 104. The difference on this one, in terms of units, is that area is measured in square units. So we see feet as our units on this one. This is going to be feet squared, is how we represent it. And hopefully this is not new to you. But what I'm finding is that people still need some practice with it. So I highly recommend the practice. But on letter B here, what we have is we have an obtuse triangle. Our obtuse angle is here, more than 90, to refresh our vocabulary. And we know that the base, then, in this particular triangle is 10, and the height outside of the triangle is 8. And then we can fill in the formula. It's 1/2 times 10 times 8. And if we type that into our calculator, again, I use 0.5 when I type it in just to be a little bit quicker, but 0.5 times 10 times 8 gives us 40. So our area is 40. Our units on our triangle in this particular case are inches. So it's going to be inches squared. Area is measured in square units. Letter C, a right triangle. So we can identify, in this particular case, the fact that our base is 7, our height is 10. You could mix those up if you chose. So when we fill in our formula, area equals 1/2 times base times height, and we type it into our calculator. And maybe you don't even need to type it in. 0.5 for the 1/2 times 7 times 10. And we get 35. Our units are yards squared. Find the area of this triangle. Well, it's another triangle, a right triangle, and what we see in this particular problem is we can identify the base, or we can identify the height, however you look at it, but we need to know this other side here that we're missing. We need to know this length, which I'll call A. And ultimately what that means for us is that we need to go back and use the Pythagorean theorem. And in this particular case, when we set this up, we can say A squared plus 5 squared equals 10 squared. So that's A squared plus 25 equals 100. We need to find that length of side A, which again could be a height or it could be a base. If we subtract 25 from both sides, we get A squared equals 75. And remember to undo that squared part, we're going to have to take the square root. And we'll round to the nearest tenth eventually. Square root 75 is 8.66. We're going to look at the 6 to determine what to do to the first 6. And because that second 6 is 5 or higher, we're going to round and make this 8.7. So A is 8.7. Now we needed that value because we're going to fill in our formula, which you don't see in front of you right now, that A equals 1/2 times the base times the height. And now we can fill it in because our base, depending on how you look at it, is 5. Our height is 8.7. Or, by the way, you might have looked at it as this: 1/2 times 8.7 times 5. Maybe you said the height was 5. It won't make any difference the way you multiply it on your calculator. Point 5 times 8.7 times 5 gives us 21.75. And again, we want to round to the nearest 10. So we're going to look at this 5 to determine what to do to that 7. And what we're going to do to that 7 is we're going to raise it to 8. So it's going to be 21.8 for our area. Again, it doesn't matter which way you type it in. And our units here are going to be inches squared. Area is measured in square units. Perimeter is a singular. Some of you need to see it, maybe more than you think you are. But when we're finding the area of a triangle graphed in the coordinate plane, it's the same concept as example 1, except that we need to count to find our height. So we're used to that. We had to count when we were working with our perimeter. It's the same idea here. Luckily enough, on our first example, we have a right triangle. So we want to find the area, but we don't have to do a lot of extra on this one. Our base, 1, 2, 3, 4, is 4. our height is 1, 2, 3. Counting the boxes. In our formula, once again, area equals 1/2 times base times height. So we get area equals 1/2 times 4 times 3. And hopefully you don't even need to type it in. If you do, that's fine. But we get A equals 6. 4 times 3 is 12. Half of 12 is 6. And then I'm going to put U squared for units squared. Area is measured in square units. Not always as straightforward here, necessarily. This triangle is an acute triangle, and we can find our height. It's going to go, if I can draw it in, from here to here. There's our height. So I can't get my box in there, but we can identify our base. 1, 2, 3, 4. Got a distance of that. Our height is 1, 2, 3, 4, 5. So base is 4, because I can't write very small over there. Height is 5, and we fill in our formula. 1/2 times 4 times 5. That's going to be our area. 1/2 base times height. So our area then, 4 times 5 is 20, and half of 20 is 10. If you need to, type it into decimals, type it into your calculator, but we get U squared there, unit squared. The next one, we have an obtuse triangle. So we can identify the base fairly well. Our base is going to be segment UV. When we look, 1, 2, 3, 4, 5, it's going to have a length of 5. Now that we found the base, we need to find the height. So remember, in an obtuse triangle, the height's going to be outside of the triangle. So here's the height. 1, 2, 3, 4, 5. The height is 5. And we probably will have to use our calculator this time, but maybe not. Area equals 1/2 base times height. And when we multiply here, half times 5 is 25. Half of 25 is 12.5. Again, if you prefer, on a calculator, which is being temperamental, 0.5 times 5 times 5 is 12.5. Don't even have to worry about the rounding on that. Letter D. It's an acute triangle. The height is inside of there. But do you know which side is the base? Again, I know this isn't necessarily brand new to you, but the base in this particular triangle is segment FD. And it's 1, 2, 3, 4, 5. So that length is 5. The height of an acute triangle is inside. So it's going to be roughly here. And when we count, we've got 1, 2, 3, 4, 5. And the nice part is, at least that we've done the calculation already, because it's 1/2 times 5 times 5. I should have written the fact that height equals 5 as well from counting. And when we multiply that together, it's the same computation that we did on the previous example. So this gives us 12.5. And again, area is measured in square units. So as we flip over to the next page here, it's important to note that the height of the equilateral triangles bisects. So here comes that vocabulary again. Bisects the base of the triangle, meaning it cuts the side in its cuts the side that it's intersecting there. I've got a word that's wrong, in half. So if we look at diagram 4 here, equilateral triangle is what it is. Triangle ABC, equilateral triangle. The height is going to cut side BC in half. So each part there is in half. I didn't say that very well. But it bisects. It cuts in half that other side. Same thing with the isosceles triangle here. It's going to cut the length of the base. The height is going to cut the length of the base in half. So BN is going to be congruent to NC. We just need to know that when we come to find our area of our last two examples here, with the equilateral triangle on example number 4, we want to find the area of this triangle. So a couple things that we know in this particular case is if it's equilateral, this side length is 12 and this side length is 12. But when we draw in the height of this triangle, what happens is that it bisects. So 1/2 of the triangle now is going to be 6, and the other side is also going to be 6, because 6 plus 6 is 12. Half of 12. And what we need to do on these remaining two triangles is we're going to have to calculate the height, going back to using the Pythagorean theorem. And we've got 6 squared plus h squared equals 12 squared. 36 plus h squared equals 144. We can subtract 36 from both sides, and we get h squared equals, well, 14 minus 6 is 8, and it looks like 108. And then lastly, what we need to do is we need to take the square root of both sides to find our height before we can figure out what our area of our triangle is. So the square root of 108 is 10.39. When we're rounding here, we have to look at the 9 to determine what to do to the 3. Because 9 is 5 or higher, this is going to be 10.4. There's our height. And once we've got the height, then we can put that value back into our formula to finish here. And it's going to be 1/2 times 12. It's the whole base. 1/2 times 12 times the 10.4. And we type it in. Again, 0.5 for the 1/2 times 12 times 10.4 will give us our area of our triangle, 62.4 yards squared. That's the equilateral triangle, but the concept works on isosceles as well. When we finish here, we do have isosceles. We've got a side with 12 feet and another side with 12 feet. And what happens is our height is the dotted line drawn in there, but we need to figure out what is that height. So we'll call that h. But the base of this triangle is 7. So what happens with the height is that this side now becomes 3.5. And this side becomes 3.5. And we need to use that to help us find the height by using the Pythagorean theorem. So this becomes 3.5 squared plus h squared equals 12 squared. And 3.5 squared is 12.25. So we get 12.25 plus 8 squared equals 144. We're going to subtract 12.25 for both sides. And we get h squared equals 144 minus 12.25 gives us 131.75. And once again, to undo the squaring, we need to take the square root. So we're going to end up with h equals, well, the square root of 131.75. This is 11.47. And when we're looking here, we're looking at the 7 to determine what to do to the 4. And we're going to round it up because 7 is 5 or higher, so we're going to get 11.5 for our height. And then we can finish finding the area. So the area equals 1/2 of the base, the whole base, times the 11.5. And then we can finish. Type it in. 1/2. So 0.5 times 7 times 11.5. And we get 40.25, which we want to round to the nearest tenth. So one last time, here the 5 is going to cause us to round our 2 up to 40.3. So our area equals 40.3, and our units on this one are feet squared.